Hello once again. Here is your Unit PB video key for the semester exam. We have to use quadratic formula for this one. So if you remember the quadratic formula, is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a, where this number right here is a, this is b, and this is c. Sorry, make sure you take the negative with it. This is your c value. Be sure to do that for the 7. If there was a minus sign here, b would be -7, or if there's a negative right there, a would be -3. And so you plug these numbers into this formula here. This formula is provided on the exam itself, but you can also put it on your cheat sheet. So in any case, you get x equals -7 plus or minus the square root of 7 squared minus 4 times a, which is 3, times c, which is -3, all over 2 times a, which is 2 times 3. And then simplify this. I would just multiply these first. This is going to turn into addition because I have 2 negatives. And then we have 49 here. So I'll kind of show this step. So now we have -7 plus or minus the square root of 49 plus, this is 12 times 3, so 36, all over 2 times 3, which is 6. And then that equals -7 plus or minus the square root of 85 over 6. And then you have to check to see if the square root of 85 is a number that you can simplify, because if it has a perfect square factor. It does not, however. And then lastly, if you were able to bring a number out of the square root because of a perfect square factor, which you would write right here, then you do check this number, the number that you bring out here if there was one, and this number, if they're all divisible by the same thing, then you can divide it. But since these two aren't divisible by the same thing anyways, then there's nothing to do even if you were able to simplify the square root of 85. So there you go. The discriminant is just the number under the square root. So it's the b squared minus 4ac. So for the particular problem we just got done doing, that is 85. And that will tell us the number and type of solutions we have, which is what these next 3 problems are. When your discriminant is positive, like it was up here, you get 2 real solutions. -7 plus this number divided by 6, whatever that is. -7 minus this number divided by 6, whatever that is, but it gives you 2 different real solutions. So 2 real solutions. When your discriminant is negative, so you have a negative number under the radical. That's when you get 0 real solutions. It also means you get 2 imaginary solutions. That's that number I that we've talked about. And when your discriminant is 0, you get 1 real solution. And that is because when that part is 0, so if we come up here, if this number is 0, then square root of 0 is 0. And it's basically like this is just 0. And so you get -7 plus 0 and -7 minus 0 are the same number. And so you would get the same answer twice, which means you get 1 real solution. Okay, graphing this function, you can just graph it on Desmos. And then you're just answering questions about the characteristics of the graph. So we have 2x squared minus 4x plus 1. Okay, and then our key points, well, that's the y-intercept, so sometimes that matters. But identify the vertex. The vertex is the lowest point, so that is just -1, 1. So our vertex is -1, 1. Remember, our axis of symmetry is a vertical line that goes through the vertex, so x equals -1. If I plot that over here, you'll see oh, whoops, I wrote the wrong thing. It's 1, -1, sorry, wrote that incorrectly. 1, -1, which means our axis of symmetry then is x equals 1. And there you can see how that just goes through the vertex and it splits the parabola in half, essentially. How many times does the graph cross the x-axis? Well, you can see from the graph twice or 2 times. The y-intercept, it is going to be just this number when the quadratic's written in standard form, but you can also get it from the graph just by tapping that point. So it's 0, 1. And this function has a minimum because it has a lowest point right there, which is the vertex. And what is the value of the max or min? That means the y value. So the min is the y value of the vertex, which is -1. Okay, if a quadratic has imaginary zeros, what does that mean? It means the graph does not cross the x-axis because zeros graphically are the x-intercepts. But if the zeros are imaginary, that means the graph does not cross the x-axis. So the graph does not cross the x-axis. Okay. Now we're just going to kind of answer the same types of questions. I'm not going to read the problem. You can do that. But the function is -16 t squared plus 90t. And you can just use x on Desmos instead of t. So you can see we have an upside down parabola. It goes pretty high. What is the maximum height of the ball? That's the y value of the vertex. So 126.5625. 126.5625. And this is measured in feet, I believe. It doesn't say it, but it should. It actually is measured in feet. I know that from the equation. That's not something you would know. The problem should tell you that. How long is the ball in the air before it hits the ground? This is measured in seconds. So when it hits the ground, that's a y or an x-intercept or a 0 of the graph. So 5.625 seconds. 5.625 seconds. Okay, that's it. And this next one is -16 t squared plus 62t plus 35. What is the maximum height of the cannonball? Again, the y value of the vertex. So it's 95.0625 feet. When does the cannonball reach its maximum height? That's just the x value of your vertex, which is 1.9375 seconds. Five doesn't look very good. There we go. How long does it take for the cannonball to reach the ground? These are a lot of the same question from above. So that's the x-intercept right there. So 4.375 seconds. And how high is the cannonball off the ground at 1.25 seconds? So for this one, probably the easiest way is just make a table and type in 1.25 and get your y value of 87.5 feet. That's the easiest way to do that, I think. Okay, now just looking at a graph over here. What is the vertex? So that's this point. It is at -1, 9. What are the zeros, which are also the x-intercepts on a graph if they're real? So you have 2 and -4. Those are x values. X equals 2 and -4 are the two different zeros. The domain for this graph is going to go like this and keep getting wider and wider. So the domain is actually -infinity to infinity. That's true for all quadratics when it's not a word problem. And then lastly, what is the range? That is the lowest point. It goes down forever. So -infinity up until the highest y value, which is 9. So -infinity to 9, bracket on 9 because we are using that point. Okay, multiplying here. So some people call it FOIL. I call it double distributive property. So all I'm going to do is distribute the 2x. So 2x times 4x and then times -1. So distribute. And you get 8x squared minus 2x. And then we distribute the +5. So again, +5 times that and +5 times that gives us plus 20x minus 5. Then you just combine like terms, which will always be the two things that have x in it on a problem like this. And so that gives us 8x squared minus 18x minus 5. Okay, solve by factoring. 28 is the tricky one. We'll get to that, but when your leading coefficient is 1, we are just double bubbling and finding two numbers that multiply to get this and add to get that. Multiply to get this and add to get that, as long as it's equal to 0. Even on this one, we got to make it equal 0 first. So this is going to be x minus 7 times x plus 5 equals 0. And you set each of these equal to 0 separately. And you can show that if you want. I'm not going to. I'm just going to say x equals 7 and x equals negative 5 from your two bubbles. Remember, it's the x value that makes each bubble equal 0. And again, negative 7 and 5, because negative 7 times 5 is negative 35, and negative 7 plus 5 is negative 2. Okay, this one's multiply to get 20 and add to get 9, so that's 5 and 4. And so we get x equals negative 5 and negative 4. Remember, on a graph, these are your x-intercepts. Don't like my rectangles today. Yay. All right. On this one, we got to make this equal to 0 first. So it's 6x squared plus 7x. Subtract 20, so you get minus 5 equals 0. Now when you double bubble, it is just guess and check. I'm going to put 3x and 2x, because these two things have to multiply to get 6x squared. So it could be 6x and 1x. But then the numbers that go here and here have to multiply to get negative 5. So it's going to be, let's see, negative 1 and positive 5 here, I think. And I'll show you why that's right if it's right, and if it's wrong, I'll show you why it's wrong. But in either case, 5 times negative 1 is negative 5. So you're always doing this times this to get this, and this times this to get this. Then we check to see if this is correct or not by doing 3x times this, and then this number times that. We already know that these are right because that's how we chose these numbers to begin with. But if you want to just FOIL the whole thing, go ahead. If that makes more sense to you. But I'm going to do 3x times negative 1 and get negative 3x. And I'm going to do 5 times 2x to get plus 10x, which is in fact 7x, which is this. And so I know I factored it correctly. And so this is still set equal to 0. So now I can set each of those equal to 0 separately. So 3x plus 5 equals 0. And 2x minus 1 equals 0. And solve. So 3x equals negative 5. X equals negative 5 thirds. And the blue one, add 1, you get 2x equals 1, or x equals 1/2. And so that's how you do that. All right, solving by completing the square now. To complete the square, remember, look at what has the x's. Forget about this number. We don't care about it for now. We can move it to the other side if we want. But in either case, you're going to divide this by 2 and square it, which is 9. So it's x squared minus 6x plus 9. We're going to add that 9. And I'm going to add that 9 to the other side as well. And then I still have this plus 13 right here that I didn't do anything with yet. So you can subtract the 13 to begin with. In fact, let's just do that. So equals, I'm going to get rid of that for a second. So backtracking a little bit, let's just say I subtracted 13 first, so I get that. Now I divide 6 by 2 and square it, so I get 9, add 9, add 9. Or if you remember, you figure out what number you want this divided by 2 squared, and then just turn this into that number. So to turn 13 into 9, I could add negative 4 to both sides. So that was the other way we did it. But what that does is it makes the left side double bubbleable, always, into whatever b over 2 was. This number divided by 2 is always going to be that. And so it squares. And now we can solve it by square rooting, equals negative 4. Now in this one, we square root both sides. When you square root both sides, throw your plus or minus in there. Which, squeeze that in there, right there. And then you get x minus 3 equals plus or minus. Now the square root of 4 is 2. So the square root of negative 4 is 2i. And now you can add 3 to both sides, and you get x equals 3 plus or minus 2i is how you rate that. Can't actually do anything with it, so not too bad. All right, 30 is the similar problem. It's we're going to get to the same step, actually. Get the thing being squared by itself. Sometimes there's another number out here, like plus 10 or whatever, and then you subtract 10 first, then get rid of the 1/3. I'm going to multiply by 3. Give me x plus 5 squared equals 21. Now I can square root both sides. And remember, when you square root both sides, get your plus or minus there. So that gives me x plus 5 equals plus or minus the square root of 21. Check for perfect square factors of 21. There aren't any. It's just 7 and 3 are the only options. And subtract 5 to get x equals negative 5 plus or minus the square root of 21. And there you go with that. And then finally, simplify the square root of 80. Just a quick reminder. Find a perfect square factor, so 16 and 5. If you don't find the biggest perfect square factor, you might just have to do this process twice, which is fine. Just always check what the last number you have underneath the square root and see if you can simplify it further. So the square root of 16 is 4. We did not do the square root of 5 at all. It just stays there. Notice there's no plus or minus on this problem because the problem already had a square root. Unlike when we were solving up here, when I square rooted both sides, then I had to put the plus or minus. Okay, and remember, if this were negative 80, nothing would change except it would be 4i radical 5 instead of just 4 radical 5. That's all the negative under the square root does for you. All right, hopefully this helps. You can watch it as many times as you want and use it as preparation for the midterm.